Hello and welcome to Practicalli. I'm John Stevenson and thank you very much for joining me. So today we're going to round off, I was going to round off the data science visualization we've been doing, although I've still got a few more to-dos to do. But we'll have a look. We put the application together so it's easier to follow. The code we've been developing in the design journal is now in the application itself, and that's all being pushed to the COVID-19 dashboard GitHub repo. I did that just this morning, so if you want to go and grab the code, the link is in the chat window. It's essentially the this repository here. No, that one there. There you go. So if you go and look at that, all the code's there. Just pushed a whole bunch of stuff there, so you should have 30 minutes ago is the latest version. We're going to walk through the changes we've made to the project and see how far we've got and look at the results. So we'll have a result that looks like, find the right page. Oh, I have to reload my specification. If I go back and run the dashboard, and then hopefully it's still working. There we go. So you've seen this dashboard if you've seen the other videos. So we've got the headline figures, we've got a line plot, and we've got a Geo Jason thing with lots of different colors on. And so we're going to walk through that. Unfortunately, the yellow ones are probably broken because they're not showing the right values, but we'll talk about that during the thing and my plan to fix that. Okay. So before we get started, just a reminder that all my videos are on Practicalli website, and also the books. There's a lot more updates in the SpaceMax book recently, and I'll be doing some more in the Clojure book in the coming weeks, and the web apps one as well. I'm going to add some more libraries to that. It's covering Ring and Composure. I want to add Composure API and a whole range of other frameworks you can use for back-end web development. If you want to reach out and get in touch, then it's the Clojure in Slack Practicalli channel is a good place. Or you can also DM me on Clojure in Slack, and if you don't have an account, then sign up here. And also there's plenty of people joining my videos, and I think if we go to YouTube, I don't know, I think we're over the 400 barrier now. Let's have a look. 410 subscribers. Whoa! Thank you very much. That's a nice that's a nice boost for my motivation. So thank you very much, and thanks to everybody who's donated either via PayPal or GitHub as well. I'd just like to especially call out Clojure together. Clojure is together, who've also sponsored me to do some work on the books as well. So I'm going to write some more information about this. But if you, I think it's announced on the projects. It's not there yet. Okay, there is an announcement that we're funding. I'm being funded by Clojure is together, so I'll be able to spend even more time on the books there as well, so that'll be helpful. I also have more time to spend on these broadcasts as well, make them a little bit more polished, hopefully. So if you have any questions, then please ask in the chat, and if not, I'll crack on with explaining what the changes are. Okay, so oops, that's the wrong. No, there we go. Oops. So this was the dashboard before. We didn't have the Geo Jason, and we've added that now to this bottom page, and we've got the tooltip that's hovering over this, and this is using the right data now. So this is using data for a specific date. Before I was counting up all the cumulative dates, cumulative cases values. So this is the reported cases that are actually recorded. So these are reported cases in English hospitals. they're not cases anywhere else, and it's only from the gov.uk dataset, so there may be other things that aren't included in this. But it's giving us more, where we don't have -1s, the data is accurate. And I believe the data we've got is -1 because the name of the region is different in the two different data sets I'm using, but I'll go through that as well. Okay, just as a quick recap, let's go here. So all the project is in here, and the project is laid out a lot better now. There's still some improvements I'd like to make, but we've got several namespaces. So we've got the COVID-19 dashboard, which is the main namespace. Make that bigger. There we go. And this pulls in some Vega-Lite components as views. So this is where we're defining the data structure for our views. So this means that this dashboard, this is our kind of main, this is our core namespace, and it means that you can kind of just look at this, and all the rest of the kind of details is abstracted out into these other namespaces. So Vega-Lite components, we just have those as views. We've got view helpers, so they do some of the transformation, and we've got data.gov, which is our main source of data. There is also a mock data namespace, but now we've got the real data working, I don't really need to include that anymore. And then the dashboard we've got, again, is just a def, which just defines this hiccup syntax. So it's just basically doing the HTML tagging, and it's got a style sheet, which is using the Bulma CSS thing for the headline figures. So that's the top of the dashboard, and then we've got so this is still a little bit more involved because it's basically just generating the data for kind of the web page itself. So if we go back to so it's generating all the HTML for this section. So I could actually just split that off into its own namespace as well, really, or put yeah, that sounds like a good idea actually. And then that would make it clear, and then we could just have a function that returns the separate like each individual sections. So we've got the div for the headline figures, which is all of that, and then the rest of it is just this. So if we go to, so these three lines are everything after this part of the page. So these three lines are these graphics. So if we actually replace the code with a simple function, put that into a namespace, then we could make the dashboard really, really simple. And then we could just go and look at the pieces of code we actually are most interested in. Yeah. So what I'll do is I'll pull all this code into a function that just generates this, and then that makes the dashboard a lot simpler. And if I can, boom, boom. No, it doesn't. There we go. And then we just have a dashboard with just the various sections. So I'll probably put a section here, and then with the maybe with the heading and for the page template, and then the headline figures, and then this section for the Vega views. So this is how you include the Vega-Lite views in the dashboard when you're using HTML. And what I've done is also put, just to aid a bit of debugging in the project. So all these views I've created are all defined in this views section. So they're just defs that define a data structure, and then so we can view that data structure using Vega-Lite. key here in HTML, or we can use the Oz view to do that as well. This is working exactly the same. But in this case, we're actually, if we evaluate these, then we can just view the individual Vega-like components. So this is just in a comment block, but we can go in and just evaluate a particular function. Will it let us do that? Let's see. And if we go there, then we just get that particular view. So we can just hone in and debug a particular view. So if you've got something breaking in the page, you're not quite sure what it is, you can go in and look at specific views. Or if you're trying to debug a particular view, then you can just look at that particular view and in a larger kind of scale. Boop. So that's really useful to include. So I've included the comment at the bottom of this just for debugging purposes. It makes it easier, and there's also some to-dos I'd like to do as well. So the main, I can pass a new I can pass a new value into main. So I want to make that so I can just call this on the command line and pass in a particular file, a new file. So like there's no API on the government data, so I can basically, I'll need to download it each time, and then what I want to be able to do is just be able to run main on the command line with a new file name, and it will just basically pick up all the new data that we've got as well. So if you go there, you can see this. Okay, that's the dashboard. So it's pulling in the dashboard at the moment, but we want to be able to just call that with a document. So we don't have any other views. I suppose we could have this as the view we wanted, and make this argument into a map. So we'd have something like we could pass in the view, and then so that would be dashboard COVID-19, and then we could have file, data file, and then we could pass in like the whatever the CSV file is. So we could pass in that, and then that would read in the latest thing. So all we'd need to do is just drop in the latest file into that, and we could also put in earlier files as well if we wanted to version them, but put the latest file in, and that's a quick way to just be able to run this application with the latest gov.uk info. So that's what I'm going to do next. Oops, didn't want to do that. Oh, there we go. Modify. Okay, so I think I've got that on the little to-dos there as well. Oops. Yes. So what have we actually done to make this work? Let's go back to the design journal. And go to the new data. Where did I put it? New gov.uk. This is getting quite a big file now. Where did I put it? Oops. Yeah. I thought this is in the right place, so I'll just need to find it, and then we'll be good. Where are we? Where are we? Where are we? Where are we? Oh, gone past it. There we go. I did put a mark on here, but I think I've forgotten it. There we go. Oh no, where's it? Where's it? Where's the bit I was looking for? Okay, right. Yes, here we go. So what I was trying to do is trying to get the where are we? There we go. So I was updating the cases data, but I was so I could get the kind of maximum value for the scale, but I was trying to pull in. So when we're joining the, so let's start again. So when I'm joining the Geo Jason dataset with the cases dataset, with the cases dataset as it is from gov.uk, it's got basically an entry for every day for every district. So when you want to try and get out the total number of cases in a particular area, then you need to find either the biggest value or the date, and I was basically going and trying to pull out the district by the area name, and using the feature as we were sort of cycling through the data set of the Geo data set. We cycle through the features, which are the individual districts that it has, and pull out the name of that. And then for each name, I would go and get the confirmed cases from that. I get the area name and pull out all the areas that matched. So we'd have the matching entries for each district. But because there are multiple ones, then we're getting multiple data sets. So if we look at, so if we actually look at the data. So in here, so in the Geo Jason one, there's only one entry for each district. But in the cases data set, then we have multiple. Oops. Where is that? We have multiple entries for each data. So this is where we generate the. We're just getting the. We're taking the combined cases and just getting the local authority ones. So that's what we're doing here. Just basically filtering out. Let's look at this. Yeah, that one. So we're just basically filtering out by area type. And we're getting the upper local tier authority here. Oops, I don't have that. Don't have that evaluated. There we go. Oops, what's it forgotten? What's it stuck on? Oh, UK. Oh, it doesn't have that UK combined cases. So I'm just using a go-to just to jump to the definition. There we go. Oops. Oh, that doesn't have that either. Oh, it doesn't have that. I did restart my REPL, so that's why things are not in there. So there we go. Okay, so this should be able to do that. There we go. There we go. So this COVID cases, this is all the combined cases, but we're filtering out just for the local authority. So if we look at that, why didn't that work? Oh, cider inspect last result. Why is that? Oh, what do we not? We've broken it. I don't think I'm getting any. Oh, getting any values. Let me see. So this is the Geo Jason structure, and so we get this local. So we get features, properties, and we get the local district name in here. We get single one. And but in the gov.uk things, we're getting multiple. So we'll get multiple entries for each district. Let's see if I can find. So we get this data set. So we get like the backing and Dagenham. We'll have multiple ones of those for each specimen date. So it'll have multiple days. So that'll have like over 30 entries for each of the area names, because it'll have like around about 30 days worth of data that's been recorded by now. And so then what I was doing before was I was taking the cumulative lab confirmed cases, and it was adding them all up, so it was getting much higher figures. So what I wanted to do was just filter out and get the latest value of confirmed cases. But then it's quite tricky to filter that out, and then I realized that actually I can just filter that out just by using date. So that's what I did. So I did spend a bit of time trying to figure out how to filter these, and tried a few different things. And I was using rand int, which was a kind of if I don't find any value, it'll create a random one, which was handy initially just to see if the visualization was working, but then it kind of masks the fact that it's not finding the right information. So then we got to yeah, and even kind of passing the cumulative lab confirmed cases and adding them up to get so finding the maximum there for the scale. So I was using this value for the scale here. That was, the scale was wrong, and I was getting black colors because values are going off the end of the scale, because I was adding them past the top of the scale as well. So when I was doing maximum cases, this calculates like the biggest case reported. So it would probably find the latest. It would find the latest report of cumulative cases. So one of those would be the biggest. But when I'm adding all the cumulative cases up for a particular district, and so you're basically adding 30 values together, which is obviously going to be bigger than the maximum. So there was a few things. So I wanted to try and filter out, so I could just have kind of the latest snapshots rather than having all of the different districts adding them up. And so we tried a few different things. Let's see, we've got here, where's the section? So I tried the aggregates, I talked about that last time, and there was also transform as well. Here we go. And then, yeah, so this then did spend some time trying to figure out how best to fix this update function. So this update function is the one that updates the Geo Jason. So basically combines the Geo Jason with the cases data. And I tried all sorts, but I was kind of, I'd kind of got myself focused on just doing it based on the district name rather than one of the other values. And I didn't really find anything I particularly liked there. It just didn't quite work in the way I wanted to do it. And it was also quite complex. And I was thinking I could have done this with a reducing function, but it seemed like there was a lot of work there just to do something that was fairly simple. And so what I basically did was try and go back right to the start. And so I transform the cases data first. And also working with a slightly smaller data set as well, because trying to push debugging through the OzView is quite slow because it's pulling in the whole entire Geo Jason file, which has got all the coordinates, X and Y coordinates, to draw all of the individual districts. So it's quite a slow process to debug that, even on my machine, and my machine's quite quick. So I wanted to be able to create a specific view based on location, but it still wasn't quite what I wanted to do. I still couldn't quite get what I wanted to achieve, because basically I wanted to just filter out and get the kind of the maximum value there. It was kind of getting close, but it was just messy. I was using into and reducing functions as well. So what I did decide to do is go right back to the starting data, which actually made a lot more sense. So go back right to where we started with the extracting from the hash map. So previously I'd extracted it, and then we'd turned it into like the basic Clojure data structure with read CSV, and then mapifying it, turning it into a nice map that would work very well with the Oz view, because the Oz view basically just reads through a map structure. So rather than do that, rather than try and filter out through the name, which kind of did work okay, we still got multiple multiple occurrences of each name, and then I'd have to kind of do the same thing for each one. It seemed a lot of work when I could actually just do that when I was extracting the data and actually create a more specific view there. And I realized, well, actually the dates are just strings, and strings are very easy to compare. So what I can do is rather than try and filter out by the district name, if I just get the latest entries, the latest dates from all of the districts, then I've only got one value for each of the districts, and it just makes everything far simpler to do. So yeah, sometimes it is worth like stepping back, having a bit of hammock time, and thinking, well, okay, is there a simpler way to do this? And there was, and this is much simpler. So if we actually, rather than give the whole data set to the Geo Jason view, which we're not going to use most of it, we can actually create a specific set of data for that view, and it makes the view so much easier to work with as well. So like you can consider the view as like the user interface for the data set, and so the more appropriate the data set is for the view, then the easier it is to create that view user interface. So rather than mapify it straight away, it's a lot easier to actually filter things when they are vectors as opposed to maps. There's a lot less code involved, and you can just use a simple filter function. So what I'm doing is I'm going to create I'm going to extract the gov data as normal. So this is the combined data set for all of the districts for all 30 days. So all the information is in here rather than it being split across several files as it was before. So we're just going to extract that from the CVS file that we've got, that we downloaded. And I've added that to the project now as well, so you can try this out. You don't need to download anything. And then it's just getting that data source, that link to the local file. It's getting a handle to read that file. It's slurping in as a string, and then we're just converting that into a Clojure version of the CVS file. So this is just basically a sequence of vectors. So we evaluate that, and we go and look at the inspector. Then what we see, so it's saying here it's a lazy sequence. So it's basically just a list of vectors, and then each vector is got the area name, code. This is the heading, so we don't have any data in here. But if we go into the actual here, then we've got the location on the Geo Jason, and actually you could try and see if those match up on the Geo Jason one. Then we got the type of location is, this is a country, so this is the data set for England, and then the date, which is a simple simple string format, and then the total cumulative cases. Which means that we can actually go in and if we want to maximize that, make that 25. Then we can scroll through, and you can see there's a lot of, and we're going through, so you can see that there's multiple buries going through there, and because we're going through A and B, there's another bury at the top there. So we're going through, there's lots and lots and lots of entries for each of these districts. So what we can do is just take that and filter out for some date. So we've got a little helper function here, so data set specific date, and it will basically take the extracted data set, which is this data.gov.uk, and it'll only return the dates that match, and then what we're doing is also because the heading doesn't have any dates in it, it would filter that out. So we're grabbing the heading first, just by grabbing the first element of the lazy list of the sequence, and then we're just conjuring that back onto the results of filter. So we filter and we just get all the entries for a particular date, and then add the heading back to the front. So we kind of, this is our results of our filter, and then we conj on the headings, and then we get the right results. So we get the headings put back on. Because it's a list, a sequence, then it's going to put the additional value at the start of that, because that's how you add things to a list in a performant way. So this gives us just, this basically gets rid of an awful lot of data, so which makes the debugging a lot faster, because you've got a smaller data set. And we've just got the dates for whichever date we pass in. And so if we can pass in dates like the data set and the date that we want, and then we can turn that into a map, and we can do the heading. So we pull out the heading because we still want that heading. What did I do here? Oh yeah, and so now we're doing the extract for a particular date, but now we're also adding in the mapify, and we're keeping the keywords as strings because they've got spaces in. So now when we do this data set, we've got a lot smaller set of data to go through. 25, set to 25, boom. And yeah, so we've only got 7 pages of data, which is a lot less than we had before. So we probably have like 30 times that approximately in the normal data set. So now we can just look at particular dates, and we could also use this approach to basically scroll through different days. So we could actually walk through like the headline figures of each day. So if we go back to boop. Yeah. So we've got the headline figures. We could actually have like a scroll button that would actually go back and like show me the day, show me the figures for a particular day, and we could just generate those data sets on the fly very easily, and then we could kind of see the headline figures if we wanted to, if that made sense to end users. One thing I forgot about was to extract the local area district currencies before that map, but we'll come to that a little bit later. But this makes the joining of the Geo Jason dataset and the cases data a lot simpler. We're just basically pulling in, getting the values from the particular district recording that we've got. So if we've got Hartlepool, we get the values, we filter out that for the name, so we're getting the right name of area. So we just return here just a single area that we're looking for, which is matched on the feature, which is the Geo Jason feature. And we get the name from the Geo Jason file, so that'll be, so we get Hartlepool from there, and then we look at the values of the gov.uk thing and pull out the values there, and if one of those values is Hartlepool or the same, well, if one of those values is the same as the name of the current feature, then we keep that and we throw everything else away. So we just get one single district in here, but it filter returns that as a list, as a sequence of results. So this will return like a sequence of maps, but there's only going to be one map in it, and that map will be the map that has the same district name. So we get the first, that will return the map, and then we can just do a normal get from there, from the cumulative, from that, and just pull out the cumulative lab confirmed cases. And if it doesn't find anything, then it just returns -1 as a way to show that we're getting an error, because we don't record data of, like, we don't record minus number of cases. So we know that that value is definitely a particular error. So that makes the update of the Geo Jason and the UK data a lot simpler, and it means it works properly as well. So that's good. And so when we go and inspect so this is the joined Geo Jason. So we've got all the properties from each of the districts in here. So if we look at that, so that's basically just a vector of all these maps, and each map is the data of a particular district. And you can see that we've got cases here, 75, which is the total recorded on the 14th of April for Hartlepool. And we've got cases for other regions as well. So we can see the cases data there very, very nicely. So that's working quite nice. But then we want it to filter out the particular, what did I do there? Oh yeah, so this is just me so this is how the filter is actually working, just with some simple data. So you can see when we do the filter, it's taking out a list of maps, and then if we just get the first of that, because there's only one entry in there, then we get the map, and then we can do the get on the map as well, and we get the right result, which is the result we want. So then we can put that into the values of the OsView, and we have the right value that we want, and so that draws it up nicely. Except for the fact that we're getting, I couldn't use the maximum cases in here because it's pulling out the maximum cases. It's looking at the cumulative cases for England, which is everything. So that's if we use this for the scale of the view. If we go here, I'll just remind you what the scale is. So this is the scale that we're using, and so this is relevant relative to the maximum number of cases. But if we include the England cases, then this scale is going to be way off the chart, and everything's going to be on more or less the same color. So we want to get the maximum kind of cases value for across all the specific local area districts rather than for England itself. So at the moment I just put in, initially I just put in the value of 2000 because that was just above what I saw was the maximum for a particular district. And that was just, I just did that using the darkest color on the tooltip. So basically, if you just hover over something, you can see Birmingham is got the darkest color because it's the biggest area. Because they've so London would be quite dark, except it's all split up into different regions. So collectively, Greater London is probably has more than Birmingham, but it's all split up into its like local little districts. So you pick out here, and so having the tooltip's a really handy diagnosis tool as well. So you can see that's nearly 2000. So that's why I chose the 2000 result for the maximum size of the scale. Oops. And then we want to filter out the non-district ones. So we could filter out, and again, just use normal filter. And so we've got this anonymous function which calls sum, and basically says if there's something in this set in the thing that we want to filter, that's the thing we want to run sum against. So this will be our map. There's something in there, then we can filter it out. But this would filter out the headings as well, which we don't want to do. So rather than doing that, we can filter out. We can remove, which is the kind of the inverse of filter. So filter will keep everything it matches. So this will keep everything that's an upper tier local authority and throw out everything else in the result. And remove will do the opposite. It will throw out the things that match and keep the things that don't match. So the things that don't match here will be the local authority and the heading, like the CSV heading. So this is going back to the CVS data that we had. So this is before we mapify it. We can basically throw out the countries and regions, and then we get this date specific, but just for local area districts. So if we do that, we get in the local area districts for a particular date. And so then if we look at this, oops, wrong one. We look at this, then we don't have England on here. We just have the districts themselves. So we can so this will give a correct sizing of the scale that we want. And then we can use that refinement of the data set with the function to basically update the Geo Jason with the UK cases. And then when we put that in, we can now include this scale, which starts at 0 and has a maximum value of from this new data structure that we've created that just has local area districts in there without England. So this gives the proper scale to everything. So that works quite nicely. And I think that's the main changes I've made. So then what I did was take all this and put them into what seemed to be sensible places inside the application namespaces. So we've got dashboard, we've got which has got just the rendering of everything. We've got data.gov, which is the extraction and transformation. And then there is the mock data we're not using. There's a journal which we've just been going through, and then there's the components. So I basically took the views from the design journal and put them into here. So if we go and look, so basically these are the original line plots we had and the stack bars that we had. And then I've added this Geo Jason view. So this is basically just the view that we created, that last view that we had in the design journal. We've got the Geo Jason combined with the cases data on a date specific for just local area districts. And we're doing that with getting the maximum cases from that same file there as well. Oops, where's me? There we go. So yeah, so it's the same. So this is from the date specific information we've got here, and we can just get out the maximum cases there. So we get the right scale with that. Boop. And so the only difference to this view is that we've qualified the these defs with their namespace, because I've now put these into the the data.gov.uk namespace. So this is this is the first thing I did. So I moved all the data into its namespace. So we've got some transform helpers. So just getting the maximum cases for the scale, combining the data sets there, which is it's a lot simpler than it was. And then we've got the kind of the original stuff here. So what I was going to do is move the original stuff here into, because this is kind of deprecated, so I want to be able to replace this with, instead of pulling from the older data sets, we're going to pull that from the new data sets. I'll change that. And so we've got the new data we're extracting. And so again, we've broken up the converting it into a Clojure data structure to so we're not initially mapifying it first, so we can use this extract in different ways before we mapify it, and that makes it easier to run all sorts of different filters on it and create different data sets for different purposes, and then we can mapify it with the headings, and it will generate the right views that we want for making our Oz views very simple. And I've just included the extract from the Geo Jason, which again is just a simple, actually it's probably the simplest thing here. We're just reading in the value from the Geo Jason as objects, and it converts it into a nice simple Clojure data structure, which we can use directly with Oz. So this is so we could probably any kind of Geo Jason file that we want, we could just throw it at this function. So I probably want to make this a function. So make that a Geo Jason function and make that an argument, and then we could just reuse that as well. So probably move that into a little helper function section, and then we've got the transformation, the gov data we were doing. So this is removing country and region, so we're just creating a local authority district. So basically just improve the naming I'm using here, make it more meaningful in the wider context of the application. But this is essentially doing the same thing. So we're just removing country and region from the data sets because we just want local district. And then we've got data set specific dates. So we're basically mapifying here. Once we've filtered out specific dates from the extracted data, then we mapify it and keep the keywords as strings. And so now we can call the specific data and get the particular shapes of data we want to make the view easier. So I've added that there, and then the extract from data Excel spreadsheets that they were using, I've still got that, but I'll move that to its own namespace and put a comment on that we're not actually using that anymore. Oops. What am I doing? So yeah, so the Geo Jason view just uses those data.gov vars that we've created, the values that we created. So we just qualified those, and that makes it easier to kind of see where that data is coming from. And then finally, we go back to the dashboard, and all I needed to do to add to the dashboard was add one line. So we just added that one line. So this is from the view, which is Vega components, and that just added that to our visualization. And then we can I also added it to the comment here as well, just so we can test it individually as well. And so this now works across all of the namespaces. It pulls in the right data, so it pulls in the view from here, from this views namespace, which then goes off to the data.gov.uk. So what I might make is like a data.gov.uk previous, just as a sort of record of how we did things, and sort of move that into like an older namespace. I guess if this was a production application, I'd probably do the inverse. I'd kind of create a new namespace with kind of like version 2 data, or like data with a date. So I create a new namespace so we know that that's evolving, so we're not breaking any kind of API that other people may be using. There's no actual, all the API itself in here is kind of internal. It's only, there's no exposed public API apart from like -main really. So it's a lot easier to kind of refactor. I'm not constrained with like having to worry about doing anything backwards compatible. But if you're doing a library, then you would kind of, if you're changing something like the underlying data model, I'd create a new namespace that represented the new data model that we're doing and all the functions that we're doing as well. So then you'd still have backwards compatibility baked into the library, and people can upgrade to the new version as and when they need to. So did that render? Did that still work? Did I break anything? Oh, it still works. Yeah, there we go. Still works. Oops, make it smaller. There we go. And so one thing to obviously do is make it so it sort of like fits quite nicely in there as well. So I'll play around with the size and scale of things and where I want to put things as well. So the one thing that does remain, and I had a few ideas about this even when I was kind of walking through this, was the fact that it's showing. Let's make that bigger. There we go. It's showing a lot of -1s because it's not matching up the data. So I want to have a look at the data again and see well, why they're not matching up. So I assume that like East Lindsay is not being found in the Geo Jason dataset, or it's not being found in the gov.uk dataset. But it is, because all these individual sections, they are from the Geo Jason file. And so if the name in the Geo Jason file is different to the one in the gov.uk cases file, then I'm going to get a -1 because they're not going to match. I did notice that there's like a E number in the cases data. So if we go and have a look at the cases data again, so we go to look at the design journal. So if we go and look at here, yeah, so this is the joined Geo Jason cases file, and this is the date specific one. If we go look at this one here, and if we just go and look at these, so this is area code. So I'm going to check to see if the area code is actually a better match than the actual area name, and then use that in the update function that we've got. So we've got this update case data, Where's it gone? That's the note. It's moved. Oh, here we go. Yeah, so rather than using the name, maybe I can use the actual if there's a more of a better match with the actual Geo Jason code that uses. Yeah, so these have got this LAD13 CD code. So what I can do is basically create what I was going to do is create a set of all the names from each data set, and then do a union and see which ones are matching, and see how many are matching, and see how many are kind of different in each data set. But I could also do the same thing for the these codes as well, as these area codes, and then that'll give me some idea as to why the -1s are not matching up. And I could probably just do that on the I could probably filter from the cases as well. So there's a bit more data manipulation, data exploration to do, but we've got the Clojure tools to do that, so that should be fairly easy to do. So that's probably, I was going to make this the last video, but I think I'll probably do another video just covering that particular part, just to kind of what happens when your data doesn't line up. That might be a good episode to do for next time, and then that should close off this this nice little mini series of data science visualization. Okay, there's no questions in the chat, so I will wrap it up here. And again, thank you very much for coming along. If you've got any questions, then please reach out to me on the Clojure in Slack, Practicalli, or you can reach out to me at John, John, at practical.li, and or Twitter if you wanted to, practical_li. And although Clojure in Slack is probably easiest, and if you haven't already, please subscribe. See if we can get to see when we're going to get to 500 by the summer. That'd be nice. And I'm going to publish a blog post to kind of explain what I'm going to be doing over the next few months for the Clojurists together. And so hopefully it'll give me more time to get more organized videos. And I want to do some kind of in-between videos where we're kind of covering specific topics, which and those will be scripted, so they'll be much more professional looking than the Clojure study group ones, which are fairly ad hoc at the moment. But thanks again, and we'll see you next time. Thank you very much for joining, and I hope you have a lovely weekend. Bye bye.